Hello, this is Phil Thomas, New Era Systems. Today I'm looking at really one of the original top-of-the-line Comtech EFData modems. This was the CDM-600. For many years it was the best modem they made, at least in my opinion, and in the opinion of a lot of other people who use them. So let's take a quick look at this before we jump into a brief test. I've got quite a strange collection of parts on the back of this. Now, over here we have the transmit and the receive IF. So this is a 70 megahertz modem. It will normally output the 70 megahertz to an up converter. The up converter will then change it to C band or KU band and transmit to the satellite. Coming back from the satellite, it comes via LNA, and if it's C band, it will present C band to the down converter. The down converter brings it to 70 megahertz, and then it comes back into this modem. So 70 meg out, 70 meg in. What I'm doing here is a hardwire loopback test. On the transmit side, I'm putting a 70 megahertz carrier and I'm looping it back to the receive side. And as long as I get the parameters exactly matched, the modem will show a signal lock indicating that it is perfectly in sync with the receive is perfectly in sync with the transmit. But there's a problem in doing this, and the problem is that even though I attenuate the transmit signal down as much as I can, and in this particular modem it runs to minus 20 dB, that's still too much for the input side. And it won't get a lock on the input side because it's being overdriven. So what I have to do, I put this attenuator, it's just a 6 dB inline attenuator, and all of this plumbing is simply because the attenuator is N-type and the transmit and the receive ports are both BNC. So I have to put a few adapters in there. One other item that I forgot to mention, the data port, the serial port, is being fed by this cable direct to my Firebird 2000. The protocol is set up as EIA, and what I'm doing, I'm simply testing the input-output port or the serial port on the modem to make sure there are no errors. That's what the Firebird is for. Okay, let's look at some of the features on this modem. I'm going to start with the fast option. This gives me an indication of what features have actually been set into the modem. Comtech EFData have this feature whereby they put most of the software already into the modem, but it's not activated, and it's not activated until you enter a code. And so this is a way for me to look at the features that are activated in here. We know that 20 meg is not installed. Drop in insert. 10 meg. So this is a 10 meg modem. No 8 PSK, 16 QAM. So I'm just clicking through these IBS until I can find one that is installed. Okay, so that's it. It's a 10 meg modem. Now let's see what else we can see. When we want to go up a menu, simply press the clear button. So I'm going to go back to monitor. Shouldn't see anything on the monitor because it's not doing anything, but let's just look. This is where I would normally look at the input. The receive level is worse than minus 60 dBm, so in other words it's not receiving anything, which is okay because I haven't given it anything to receive yet. Let's look at the live alarms, and the alarm is the receive DMOD lock. Again, that's perfectly okay because it's not getting any drive, and so obviously that's going to show as an alarm. Later, once I get this thing running, I'm going to go into the stored events and just clear those. There's no point clearing them now because they'll come right back with that DMOD lock. Okay, now I'm going to go to configuration, and first I'm going to look at the transmit side, because in a moment I'm going to need to go to the receive side and set up everything identically. Okay, so let's start off with the IF. Okay, the carrier is off. The power is negative 20. So the maximum attenuation on this modem is minus 20. And as I said at the beginning, that's too much drive when I'm doing this direct transmit to receive. And I can't, on the modem, I can't make it minus 25, minus 30. It simply won't go up any higher than that. So we'll have to stick with minus 20. Let's go across, look at the encoder. The encoder is Viterbi, fine. Modulator should be QPSK. Yes, we've got QPSK 3/4. I need to remember this because in a moment I'm going to the receive side. I've got to make sure everything is the same. And the data rate is 264. Okay. That's really all I care about on this. So now I'm going to go over to the receive side. And starting off, we've got the receive frequency of 70 megahertz. I forgot to check the transmit frequency on the when I was going through that other menu. Anyway, I'll do that in a moment. Receive frequency is 70 meg, so that's fine. Decoder again is Viterbi. Demod QPSK 3/4, good. The data, the data is different. The data should be 264, not 1264. So let me make that change, otherwise I'm not going to get a lock. Okay, that should do it. And there's nothing else that I really care about. Things like this, the EBNO for example. This is an alarm. If you're working with this modem in a teleport and the EBNO drops on the receive side, you really need an alarm to warn the staff in the teleport that something is going on at the distant end. This is where you set the alarm. So if our incoming signal drops below 3.1, this modem will go into alarm and alert the staff at the teleport. Okay, so I think we've got everything okay. Let's just look at the symbol rate. It's 176. Now let me go over to the transmit side and look at the symbol rate there. It's 176. A symbol rate is a combination of FEC modulation and the data. And so as I've got all three of them set, the symbol rate should be equal on each side, and it is. So now let's go back to setting up the IF, and I'm going to put the carrier on. And we've immediately got a lock. So we know that the transmit side is working perfectly, and we know that the receive side is working perfectly. Now the other thing that I care about is ensuring that the data port, the serial port, is working correctly. And on the T-Bird, you can see what you're seeing at the moment. You're seeing the number of blocks that are being transmitted and received by the T-Bird directly through that data port. And there are no errors showing. Let me just make a change to this. Normally, the sync lock light would come on if there had been any errors. And look at the bit error rate. It's showing 0 times 10 to the minus 6, so in other words, nothing. And since I just put it on a few minutes ago, it's showing 64 seconds of test. If I were doing this for real, I would leave this on for quite a long time, just so that I could be certain that there are going to be no errors. So this modem seems to be working perfectly well. It's an old modem. One time they were worth $6,000. Now probably get $1,000 for something like this. On the cosmetic side, there's something here that always irritates me that I've got to point out. These modems are mounted in racks, 4 bolts or screws holding them into the rack. What happens is that one of the engineers, when removing the modem, will take out 3 of the screws or bolts, and the weight of the modem just drags down, and then what it does, it bends this ear. It's completely avoidable, but you have no idea how many modems we see with this. It doesn't make any difference to the function of the modem, but I don't know, I just don't like to see it. But we didn't do it here. All of this happened before we received it, so there's not much we can do. So that's all for today. We've tested a Comtech EFData CDM-600 SCPC modem, and I'll see you in the next video.